today's goal of this lecture. Today I will see one question which had come CSIR NET 2023 exam about nilpotent operator about similar matrices. Today I will see one question about nilpotent operator and similar matrices. Few days ago I have defined similar matrices, properties of similar matrices briefly. At first, I will highly recommend you, if you don't see my previous video, I had discussed long day ago similar matrices briefly, and few days ago I had discussed just as a review. I had given all link in the description box. If you don't see my previous video, at first I will highly recommend you, please see my previous video. Then today's video would be more clear. At first see my previous video. The question about similar matrices and the question is, let V be a finite dimensional real vector space and T1, T2 to nilpotent operator such that V belongs to V such that T1 V equal to 0 and W2 equal to those vector V belongs to vector space V such that T2 V equal to 0. T1, T2 here two nilpotent operator, and the vector space V is the finite dimensional vector space. That means here T1 map from V to V, also T2 map from V to V, and those vector such that T1 V equal to 0 and V belongs to V belongs to this vector space V such that T1 V equal to 0 and similarly T2 V equal to 0. This is W1 and this is T1 V, those vector such that T1 V equal to 0. This set is W1. This is the set of linear operator. Similarly, this is the W2. Then which of the following statement are false? Option 1, if T1, T2 are similar, then W1 and W2 are isomorphic vector space. Option 2, if W1 and W2 are isomorphic vector space, then T1, T2 have same minimal polynomial. Option 3, if W1 and W2 equal to V, then T1, T2 are similar. Option 4, if W1 and W2 are isomorphic, then T2 and T1, T2 have same characteristic polynomial. Here notice, this is the nilpotent operator and V be a finite dimensional vector space. So characteristic polynomial of T1 is x to the power n. Similarly, characteristic polynomial of T2 would be x to the power n. W1 and W2 isomorphic means their dimension. This is actually the null space. The dimension of null space and dimension of null space of T1, this is the dimension of null space of T2. Here W1 and W2 are isomorphic means the dimension of W1 and dimension of W2 are same. But here the question about if W1 and W2 isomorphic, then T1, T2 have same characteristic polynomial. Actually, isomorphic condition not be used here. Actually, always T1, T2 have same characteristic polynomial because V be the vector space of finite dimensional. So option 4 is a right option. But here the question, which of the following statement are false? Next, see the option 3. Option 3, if W1 and W2 equal to V, then T1, T2 are similar. If you apply the rank nullity theorem here, T1 map from V to V, rank nullity theorem, by rank nullity theorem we can tell rank T plus nullity T equal to dimension of V. Okay. Here notice W1 and W2 equal to V. W1 is the null space of T1 and W2 is the null space of T2. Since null space of T1 and null space of T2 are same, that means nullity T always equal. That imply here for T1, since both dimension of both null space is V, that means nullity T equal to N. Here rank T1 equal to dimension of Vn. That means rank T1 imply this is equal to 0 operator. That imply T1 is a 0 operator. Similarly, rank T2 plus nullity T2 equal to dimension of V. Here similarly this is N, rank T2, this is equal to N. That imply T2 also 0 operator. Here I have got T1 is a 0 operator and T2 is a 0 operator. Since T1 T2 are both 0 operator, so obviously they are similar. So when W1 and W2 is V, then T1 T2 are similar. This is also right option. But here we have to find which option are false. Option 2, if W1 and W2 are isomorphic vector space. Isomorphic means their dimension, this is the null space of T1 and T2. Since W1 is isomorphic to W2, that means their dimension always same. Then T1, T2 have same minimal polynomial. Is it true? All of us know null space always represent the number of Jordan canonical form. Here null space of T1 and T2, these will be represent number of Jordan canonical form of T1 and T2. Okay. The question about the minimal polynomial, when the dimension of null space are equal, then they have same minimal polynomial. Is it implies true? At first think own self, then see my solution. At first pause for some few minutes. At first think own self. If null space always represent number of Jordan canonical form. If dimension of V equal to 3, that means this would be 3 cross 3 matrix. If null space of T1 equal to dimension of null space of T1 equal to 2 and dimension of null space of T2 equal to 2, that means for T1 there exists 2 Jordan block, for T2 there exists 2 Jordan block. Notice this matrix 0 1 0 0 0 0 0 1 0 0 0 1 0 0 0 0. Notice here one Jordan block and this is another Jordan block. But what is the minimal polynomial? If it is represent as T1, the minimal polynomial is x square. And T2 equal to 0 1 0 0 0 0 1 0 0 0 0 0 and 0 0 0 0. Notice here one block and this is another block. Then here the minimal polynomial is, since this is the block of order 3 and we all of us know minimal polynomial always represent highest degree Jordan canonical form. So since here there exists one block of order 3 and this is the highest order block, so minimal polynomial would be XR cube. Notice here the number of Jordan block is same. Here 2 order Jordan, here 2 Jordan block, here also 2 Jordan block. But their minimal polynomial are not same. For T1 this is x square, for T2 this is XR cube. Okay. But null space of T1 and T2 are same because null space imply number of Jordan block. Number of block of JC from. So this is are same but dimension same, but their minimal polynomial are not same. So option 2 is the right option because this is the false option. But here statement which of the following statement are false. So this is the false option. So this is the right option actually. Now notice option 1. Similar matrices always represent same Jordan canonical form. Okay. Since they are same Jordan canonical form, that means few minutes ago I have seen null space imply number of block of Jordan canonical form. So since given the matrix is similar, so they have same Jordan canonical form. That means null space always equal. Null space of T1 would be same as null space of T2. Because null space imply number of Jordan block, number of block in Jordan canonical form. So option 1 also right option. Today I will stop here. In my next video I will discuss more topic about linear algebra, because linear algebra, this topic is very important for any competitive exam. Okay, see you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.